So, Starship test, of course, that's right here in Texas, launched on April 20th. They had just gotten their launch license and fairly quickly thereafter launched it. Now, people joke that actually they're just kind of backed up. They've been producing so many boosters and so many engines, they pretty much had to start using them up. This was the very first test that integrated the Super Heavy booster, which is the huge one that had never been tested before, and the Starship upper stage, which is what was called Starship before, which of course has been tested suborbitally. As Elon Musk said, excitement is guaranteed, success is not, and he lived up to that, both parts. So there's a Super Heavy booster. It's shown here just after separation where the booster falls off and the Starship upper stage will go on. This test was not intended to even go into orbit. It was just basically going to send it up suborbitally and then have everything eventually crash back into the ocean. They weren't going to attempt to do landings or anything. This is typical of the testing that SpaceX would do, focus on the immediate goals, just proving out all the systems. Since the booster in particular had never been launched before, you're trying out all the ground-based infrastructure, you're trying out all the systems on the rocket. There's the fuel systems, the control systems, and so on. All that had to work, and actually it did. And we need to keep in mind that this is the most powerful rocket ever launched. Not to orbit, but just ever launched. About 17 million pounds of thrust maximum. They didn't have all of that because there were a couple engines out, but it was anyway, the rocket is basically rated at that. The next biggest one is SLS at 8.8 million, which is sort of comparable to the Saturn rockets that they used, way back when. That's a big step forward in terms of capacity, and that's what you need. If you're going to get people and the economy out into space, you need a lot of heavy lift capability, and it's also promising to be very cheap if it really all works out. Now, of course, they ran into some problems. It is a test, after all. And they did try to set expectations properly, basically saying if you get past, once you get off the launch pad, that's pretty much defined to be success. So set the bar low and you will succeed. Right away, though, there were some interesting things. Some people, including Musk, I guess, called it a rock tornado. It tore up the landing, or the launch pad, pretty badly, sent concrete and steel chunks up to 3,000 feet, damaged the tank farm where they stored the liquid oxygen, and so on. It actually not only destroyed the concrete on the launch pad, but it actually put a crater underneath it. Once you break through that concrete, it's just a bunch of dirt and sand, and that comes up really easily. And that's actually what you're looking at back here. You're looking at a sandstorm, more or less. That sand and dust got deposited as far as 6.5 miles away. And there was speculation, and it was only speculation, that the flying rocks that were coming back, bouncing back up from the launch pad might have damaged some of the engines. It's kind of hard to prove it right now because there's not much evidence left. So they're not really assuming that's the possibility, but certainly a lot of people would suspect that. It doesn't seem unreasonable. Now, there's some other things going on that people have also highlighted as possible issues here. Most large lift rocket, medium to large lift rockets, when they have a launch pad, they have a flame diverter. And what they do typically is you have something at roughly a panel that's very strong, maybe 45-degree angle. The rocket thrust comes down, exhaust, it hits it, and then it deflects it to the side. And you can see that here. This is actually the SpaceX launch pad where they launch Falcon 9s when they're launching it from Vandenberg Air Force Base in California. Here's one taking off, and you see on the lower right-hand side here, you can see the exhaust there. However, if you look closely, over to the left, then you also have where most of that flow is being directed. So it's kind of being directed off in a safe direction, not toward where tanks are and that sort of thing. They were criticized for not having even designed that in. So the question is, well, why didn't they do that? This is the Starbase launch where Starship was launched from, down at Boca Chica. And here's a view of it. And you can see pretty clearly here, if you look, you got the rocket, the tower and everything. There's basically just a big stool that the thing is sitting on, and it has a fancier name than that. It's a big stool. And there's no flame trench there. So why did they do that? Well, there was a lot of discussion about that on the internet, of course. Actually, one reason might be partially just that the water table was awfully high right there. You start digging a hole very deep, it starts filling up with water. So there are some limits. And of course, they could blind it with concrete. That's kind of a weak excuse, but it was one that did come up. Musk himself has said he prefers not having to do this, not flame diverters, not trenches, any of that stuff. Part of it's a design philosophy of cut out anything you don't actually need. And so if you can show that you don't need something, get rid of it. And that has been very successful as a strategy for them. They've actually simplified getting to space quite a bit as a result of that. But the thing in the back of his mind is really that, well, what happens when you take off, you land on the moon or you land on Mars? What happens when you take off? You're going to have a hard time building a really sturdy launch pad there. I mean, It's all possible, but it means bringing a lot more material with you, spending a lot more time developing and building this launch pad and everything. You'd rather not do that if you don't have to. And so there's a sort of a bias against having it. And so he didn't really want to do it. That's not a completely strong argument either in this case, because the vehicles that are launching from the moon or even to Mars, they're going to have less fuel in them. Because you're not launching from Earth, and most of the fuel that you use is really just to get off Earth. There's less mass, they're smaller, and you're much lower gravity. So you put all that together, there's a lot less thrust. It's not going to be as much of a problem. Still an issue, but not as much of a problem. On the other hand, this is a concern for one of the markets that Musk wants to go after. They want to do short hops on the Earth for the military. They actually have contracts with the military to look into this, delivering cargo to a combat area or something. You got to take back off. It doesn't do you much good to send it out to remote, supplies out to remote outposts and then not be able to take off again. So there's still some justification for trying to figure out ways to avoid having giant trenches and flame diverters and that sort of thing. Anyway, in the meantime, they were planning on putting a big steel plate in, and that plate would be water-cooled. And so what they do is they run water through it. It's steel, thick steel, and it would have holes in it, and water would shoot up through the holes. And having a water deluge system is pretty common. It does a lot of things. It cuts back on the dust, of course. It cuts back on the shock waves and absorbs a lot of sound. So there's a lot of benefits to it, and of course it keeps things cool. It wasn't ready in time, so they said, well, we want to launch anyway. So they have what they thought was the best possible concrete, something called fondag. It's concrete with alumina and other additives in it. You realize that, okay, it's going to have trouble, but they're hoping they could get one launch out of it. Well, it turned out they didn't. And he's still saying they'll be able to launch again. But the other thing I would point out is down here, when they did the testing, they did static tests. And normally, that's the other thing people normally do with rockets is you test them at full thrust at some point, being held down to the ground so you see what happens. They only did their static tests at half thrust. They had their thrusters, each individual thruster was throttled back to 50%. I think part of the reason was at the time they weren't sure they could run it 100%. There may be some reasons for that. But anyway, they just said, well, okay, the concrete withstood that. Let's stop testing because we know it's a little bit fragile. And it turned out it just didn't work out. The next question, of course, is, was there an environmental impact? A lot of debris was spread around, much more than normal. But as Musk pointed out, the propellant itself is not toxic in any way. And neither are sand, concrete, chunks of steel, or chunks of any of that stuff. And then the rocket itself, all that debris fell out into the sea. They designed the launch so that, if anything fails, once you're off the immediate launch pad, you're just dropping in the sea. The Fish and Wildlife Service said, no wildlife was actually killed. That seems like a bit of a stretch. It's hard to believe a couple of lizards didn't get incinerated somewhere along the line here. But, they're talking about no significant event and certainly not one that's going to threaten anything. But nonetheless, it's predictable. The FAA is being sued by environmental groups, trying to force, basically what they're saying is a full environmental review was not done. But what that would mean is literally years of review. That will pretty much stop it cold. That's the goal. And of course, if you're SpaceX, you definitely are fighting that. So getting into the tests themselves, the engines were, of course, a big issue here. 3 of the 33 engines, there's 33 engines total on the booster. 3 of them were down at launch, and it turned out they shut them down immediately or maybe didn't even completely start them up. And that accounted for a couple of things. The rocket, actually, if you watched it, besides taking off really, really slowly, which is you'd expect if you don't have as much engine power, it also was tilted a bit to the side. And the reason was that 2 of those engines were on the outside of the circumference. You can see them here. This is later on, the right-hand picture here. But like 2 of the engines that were, say, right here at the top, they were out. And so you had an unbalanced force, and so it tipped a little bit. But the big impact of all this, though, is they fell behind in terms of expected altitude versus the time since the launch. There's still the underlying question, though, why are these engines failing? I think that's a question that SpaceX is really going to have to deal with internally is the big issue. It isn't the fact that they dealt with, at least they proved that you can still take off, but you're probably not going to get it up to orbit if you want to. Now, the other bad thing is that more engines failed once they took off. At least 3, and that's why I put this picture up here. This was just taken from the ground. This is actually from the SpaceX site. And there's actually 6 engines missing, at least not firing. Those are the gaps there. Most of them are in the outer ring. Those are not gimbal. That is, they're not the ones that turn. They're just fixed. The ones that are used for control are in the center, and one of those was out as well. But what apparently happened was the damage started spreading. Shields between the engines broke down. There were visible flashes. If you watched that launch, you'd see these flashes every now and then. And of course, they have to figure out what that is. I mean, some of that could be the engine, some of that could have been broken hydraulic lines spilling out hydraulic fluid. That was actually hypothesized as the reason why they lost control. They lost hydraulic fluid. But anyway, they didn't reach the altitude they wanted to, the one they expected, probably because of losing hydraulic control. When you point the rocket, they call that thrust vector control. You know, you're pointing the thrust of the rocket so that the rocket goes the right place. They lost that eventually, and probably because of the engines. And you can see during the launch, it started to tumble. And there's some pictures down here. It's a little bit hard to make these out, but the one on the left here is 2 minutes, 35 seconds in. You'll see it's kind of going up. A few seconds later, it's already rotated, and then it's rotated all the way around. And it actually went through several of those. It was kind of amusing because the people announcing, these are from SpaceX, they went through several of these, and one of them, they finally said, this is off nominal. Yeah, no kidding. Yeah, no kidding, it's off nominal. Nobody in their right mind is going to purposely make a rocket do some extra loops. I mean, that would just be such a waste of fuel and risky. Not to mention you risk tearing the thing apart. So, they would never do that on purpose. But yeah, they figured out there was something wrong there. But there was a lot of confusion at this point because there is supposed to be a turn where what happens, there's an innovative way they're using to separate the first and second stage. The rocket starts to turn up, and they release clamps separating them. And I actually have a slide about this later. But basically, there was expected to be a place where the rocket's going to turn and then the stages separate as a result. And they kept thinking, oh, it's about to happen. But it never did. They actually never even tried to do that maneuver. But there was definite confusion about that. Some people thought, oh, there's some kind of a problem with the system for separating the stages. No, because the booster engine never shut off. And actually, that was a problem, because even after the thing self-destructed, that booster was still going. But so that says the clamps were still engaged, holding the stages together. And in some ways, actually, the biggest single concern is probably really the flight termination system. That's what happens when you decide the rocket's about to fall and damage somebody, or a lot of people, you're supposed to blow it up. And that's the flight termination system. That's its job. And it didn't really work very well. It's hard to know when it happened. First of all, it kicks in automatically. I'm sure you can override it manually, but it's supposed to kick in automatically. They said it took 40 seconds from the time that it thought it was supposed to do the destruction. It took 40 seconds before they finally got the real explosion. That's not acceptable. The regulatory people will definitely come down hard on that. They will definitely insist that a new system be put in and somehow prove it will do better. That's a killer. So it took them maybe 40 seconds. And there are several clues about that. What does it mean when you do the flight termination? The two biggest things are blowing up a fuel tank and stopping the boosters from the engines from running. Neither of those things happened for more than 40 seconds. So it was way, way too bad. You can see on the left-hand pictures about 3 minutes in, the picture on the left has a picture of the booster. You can see the flame still coming out of the booster at the bottom. So the exhaust is at the bottom. All of a sudden, something started shooting out the top up here. That wasn't part of the plan. And then if you go a little further, maybe 4 seconds later, as it's still spinning, you can see it's already rotated around just within 4 seconds. It went almost 90 degrees. You can also see there's a bunch of stuff shooting out the sides. So that probably indicates that, yeah, something was triggered, but it just still didn't explode anything. It just started letting the fuel out slowly, probably. Maybe the hole was too small and there's not enough air to blow up properly. It wasn't until almost 4 minutes that they finally got a successful test. You might say they did a successful explosion. And that's when it started, just about 4 minutes. That's what it looked like. On the other hand, it was a success. The rocket did launch. It got off the pad. It held together. Nobody knew that would happen. As I said, this was the first test of everything put together. All the infrastructure worked. The fuel got loaded up. They didn't have problems with leaking hydrogen like you had on SLS or something. The systems in the rocket itself all worked. The fuel got to the engines properly. The controls worked. I mean, the thing was doing what it was supposed to do until it failed, but at least it worked. It proved that it can work. In particular, it got past that period of maximum aerodynamic stress. We talked about that in one of our earlier meetings, that you get to a point where you're going fast and you're just getting all kinds of stress because of the air friction. You go higher than that, and the density of the air drops enough that it's not an issue. And before that, you're not going fast enough. So there's a period in there where it's really dangerous. And you got past that easily without any problem. Now, what's interesting is that even with the rocket tumbling, so the thing is already tumbling because they lost control, and the flight system was trying to destroy it, actively trying to blow it up. It held together. I mean, actually, people said, even normal rockets, you start twirling them around like that, there's a good chance they'd fall apart. This one didn't. So I think, if anything, maybe they've over-engineered this thing. They build it too sturdily, probably. So they made it up to 24 miles, which doesn't sound like much, but that is actually the highest that any of the previous Starship tests on the upper stage had ever done. So it made definite progress. Now, so what are they going to have to do? Obviously, they have to repair the launch site, replace the concrete. By now, they should be able to they'll get in that water-cooled steel plate. That'll take care of all the problems, we hope, anyway. I mean, it's not proven. It might vaporize too, but the hope is that will work. And they have to fix or damage some of the tank farm tanks, again, holding liquid oxygen, propellant, that sort of thing. One thing they're doing is they were changing over to horizontal tanks anyway, for the obvious reason that there's just lower profile to get hit. And I don't know why they don't build berms around these things to deflect upward. Some of the other sites I've seen do that. I don't know why they don't. That's maybe one thing they'd be considered.
They weren't finished yet.
Oh, those weren't finished either. Okay. Yeah, it kind of indicates that the test was kind of rushed. They wanted to get going. Other next steps related to the rocket, they decided that the engine firing time was pretty long. The thing was sitting there 5 seconds. They wanted to make sure all the engines were going because it takes a while to start up every single engine. They decided, okay, fine, they're going to cut that back to 2.5 seconds. That'll reduce the amount of time that you're exposing the concrete to all this thrust. Turns out the next booster already would have had reliability improvements because they've been building them, each one is different than the one before it. And for instance, in particular, having better shielding between the engines. Also, they're going to have electrical controls for the thrust control. And that's a big difference in terms of failure propagation because you got a common failure mode right now that if all you have to do is one engine blows up and that opens up a hydraulic system, all the hydraulic fluid goes out and nothing else can get controlled either. And you can build several redundant systems, but that adds a lot of extra weight and complexity. And actually, it's a lot simpler to have electrical ones. And so they're switching over to electrical. That takes care of that problem. And hopefully they won't lose the thrust vector control as a result. Still that open question of why are engines dying? They have to work that. And of course, they're going to have to obviously modify the flight termination system. That's a must. Just no choice on that one. So anyway, they're going to spend about $2 billion this year on Starship. This is just another photo. If you look closely, this is one of those ones where the engines are still missing, quite a few of them. I had mentioned their new stage separation thing. It came up during this launch.
We split out a separate video describing this new stage separation technique. You can find this video on the YouTube channel G Stanley 0. A link is provided at the end of this presentation. As a teaser, this diagram is part of the video showing how the Starship rotation and releasing of clamps leads to stage separation. Other space-related videos or slide presentations by me are available at the link shown here. That includes a web page and also a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.